Hi, welcome to the second lecture on the Mulligan approach. Today's topic is mechanisms and effects of mobilization with movement. I'm a physiotherapy student, Chris, and let's get things started. So, we'll start with some key mechanism domains in the state of pain. It can be, broadly speaking, classified into contributions from peripheral, central, and response system domains. With respect to the input peripheral mechanisms, we consider factors that might contribute to increased nociceptive signaling to the central nervous system. These factors might be immune or inflammatory, mechanical, neurogenic, or a combination thereof. Central or processing mechanisms are those that increase synaptic efficacy in pathways relevant to pain and nociceptive processing, broadly termed central sensitization. Central sensitization is not one process, but rather an umbrella term of a range of processes, not all of which are well understood. For the output response system, we consider protective nervous system mediated responses that might initially be adaptive, but if persistent may contribute to a cycle of pain or movement dysfunction. These potentially maladaptive responses include efferent motor, sympathetic, neuroendocrine, and neuroimmune responses. Next, we'll discuss the mobilization with movement and peripheral mechanisms. So, historically, Brian Mulligan has hypothesized the positional fault hypothesis as both the cause of a range of musculoskeletal pain conditions and the explanation for the mobilization with movement effects. Importantly, Mulligan found that the direction of the glide was critical to the outcome of the technique. It was this direction specificity that led him to speculate that these patients presented with a positional fault as the offending point, and that the externally applied force of the treatment technique corrected this fault. The positional fault could be thought of as a bony incongruence, which may occur as a result of altered soft tissue supports following a sprain, strain, or other injury that resulted in symptoms as a result of interference with the normal joint function. Although some evidence has supported suspicions that However, there's some evidence that supports suspicions that aesthetic bony alignment often deviates from the population means in some patient groups. There are so far lack of any evidence that mobilization with movement corrects such an alignment. Alternative hypothesis regarding the mechanisms responsible for the effects of mobilization with movement has been proposed. And next, we'll discuss a little bit about the altered mechanical receptive input during mobilization with movement. The application of the mobilization with movement technique may alter the force and or direction of force exerted to mechanical receptors in the applied region, which will subsequently alter the suite of mechanical receptive input to the central nervous system. Mechanical receptive input may be nociceptive, pain facilitating, or tactile or proprioceptive, generally pain inhibiting. Thus, a mobilization with movement might reduce symptoms either by reducing the nociceptive signaling or increasing the non-nociceptive signaling. And this will help support observations of like normally painful and or restrictive motion can be dramatically improved during application of an external force, a certain degree of force is required to achieve the benefit, and improvement is generally dependent on the direction of the applied force. Okay, so next we'll talk about the mobilization with movement and the central mechanisms. First, we'll begin with the part of extinguishing movement and pain associations. So, there's pain is an unconditioned stimulus and causes pain response, for example, muscle guarding, and how the pain as well nociceptive as well as the non-nociceptive stimulus can get tangled a little bit with the concepts from associative learning. So neurons that fire together wire together. So when you give a nociceptive stimulus as the unconditioned stimulus together with the non-nociceptive stimulus, the neutral stimulus, there would be a pain-related response. Over time, if you present the unconditioned stimulus together with the neutral stimulus for enough periods of time, it is considered as a period of conditioning. After conditioning, the non-nociceptive stimulus, the now conditioned stimulus, would elicit the pain-like response without the presence of the nociceptive stimulus. And this is how the wires that fire together can wire together, and that now they don't need to fire together but have a response that seem to be wired together. Okay, so how mobilization with movement can actually correct this is by the principle of extinction learning or exposure therapy. Okay, so repeating the movement in the relatively pain-free manner afforded by the application of mobilization with movement may assist to break the association between movement in the case of bending and pain. Indeed, it has been suggests that mobilization with movement might be repeated in order to facilitate relearning of previously pain-free motor memories, and this might occur through the same physiological and behavioral mechanisms that extinguish aversive memories. That mobilization with movement targets the patient's specific physical task associated with pain, and that it does so in a painless manner lends it to being viewed as a learning strategy. So, through this extinction learning, the client were able to distinguish the non-nociceptive stimulus from the nociceptive stimulus, and so the conditioned stimulus becomes back into a neutral stimulus that does not elicit the pain response. It is thought to be able to distinguish this, diminish this learned response by weakening the association and reinstating the implicit pain-free movement memory traces. And next was the central mediated inhibitory mechanisms. There is evidence that immobilization with movement activates the endogenous inhibitory mechanisms. Interestingly, there are some suggestions that mobilization with movement mediated changes in movement and movement-related pain may not be the result of these mechanisms. For example, mobilization with movement tends to both change the pressure-pain threshold and improve movement. However, improvement in movement in one study did not appear to correlate with the changes in pressure-pain thresholds. Thus, a generalized inhibitory effect does not appear to explain the effects of mobilization with movement, and thus neurological, motor, and cognitive processes associated with the target movement are more likely to be responsible for the effects of mobilization with movement that persist beyond the treatment session itself. The last part of this central mechanism is going to be the placebo effect. So the application of the mobilization with movement is able to achieve pain-free movement and so the perceived technique credibility is likely to be implicit and profound. This is particularly true for patients where the problem movement has been reliably associated with pain for some time. Without doubt, this experience can be profound to the client, who may feel reassured that the problem and the solution has been identified. And so it elicits an implicit reassurance that causes the pain to go away. Yeah. So, and then for the third part, first section is the mobilization of movement and the response mechanisms. Okay, so here is a model of the response mechanism. So for each motor command, the nervous system generates a copy of the expected sensory feedback, known as the efferent copy of the expected proprioceptive map. The actual sensory feedback, the afferent copy of the proprioceptive map, is then referenced against this efferent copy, such that fine adjustments to motor activation can be made to realign actual and expected sensory feedback. This provides a pathway whereby changes in mechanosensory feedback might elicit changes in motor activation. That is, the application of a mobilization with movement might create a discrepancy between expected and actual sensory feedback, eliciting a change in motor activation intended to correct the discrepancy. If this is the case, then it is possible that repeating the mobilization with movement technique may cause bioplastic adaptations in the motor patterning that may extend beyond the technique application. Okay, so as a summary, contents covered today include the key mechanism domains in the state of pain, mobilization with movement and peripheral mechanisms, and central mechanisms, and mobilization with movement and response mechanisms. So this is the end of the second lecture of the Mulligan approach on mechanisms and effects of mobilization with movement. I'm your physiotherapy student Chris, and hope that you have enjoyed this video and got something from it. Thank you and bye.